Some things grow at a consistent rate. Money, or the descendants of mating rabbits, for example, can grow faster and faster as the total number itself gets bigger. When growth becomes more rapid in relation to the growing total number, then it is exponential. Exponential growth is extremely powerful. One of the most important features of exponential growth is that while it starts off slowly, it can result in enormous quantities fairly quickly, often in a way that is shocking. There is a legend in which a wise man, who was promised an award by a king, asked the ruler to reward him by placing 1 grain of rice on the first square of a chessboard, 2 grains of rice on the second square, 4 grains on the third, and so forth. Every square was to have double the number of grains as the previous square. The king granted his request, but soon realized that the rice required to fill the chessboard was more than existed in the entire kingdom and would cost him all of his assets. The number of grains on any square reflects the following rule or formula. In this formula, k is the number of the square, and n is the number of grains of rice in that square. If k equals 1, the first square, then n equals 2 to the power of 0, which equals 1. If k equals 5, the fifth square, then n equals 2 to the power of 4, which equals 16. This is exponential growth because the exponent, or power, increases as we go from square to square. There are a variety of examples of exponential growth as it applies to the real world. For example, a man is believed to have brought 24 rabbits to Australia in the 1800s so that he could hunt them. However, rabbits have no natural predators in Australia, and so the population grew out of control. Within 10 years, so many rabbits had descended from these 24 first rabbits that millions could be killed without making a dent in the population. The real secret to exponential growth is this. Not only do rabbits have children, but their children have children, as do their children's children. The new growth increases just as fast as the growth you started with. There is nothing to slow the growth down or bring it to a halt. When graphed, exponential growth always looks like it is starting off slowly and then rapidly becomes steeper.